Welcome to the interface segregation principle, the I in solid. This principle is about keeping interfaces lean and purposeful. By the end of this video, you will be able to spot a bloated interface in a real code base, understand why it causes problems, and know exactly how to fix it. Imagine you design one big interface called worker with methods like work, eat, sleep, and attend meeting. Now a robot class needs to implement worker, but robots do not eat or sleep. The robot is forced to provide those methods anyway, probably throwing errors or leaving them blank. Every time a human-specific method is added to worker, the robot class breaks too, even though robots are completely unaffected. That is the fat interface trap, and it is the exact problem this principle exists to solve. Think about a Swiss Army knife. It has a blade, scissors, a can opener, a screwdriver, and a toothpick, everything in one object. That is great for camping, but a surgeon only needs a scalpel. Handing the surgeon a Swiss Army knife couples their work to a dozen irrelevant tools. Specialized focused interfaces are like specialized surgical instruments. Each one does exactly one job and nothing more. The interface segregation principle states that no client should be forced to depend on methods it does not use. The fix is to break one large interface, sometimes called a fat interface, into multiple small role interfaces, each capturing a single capability. A concrete class then implements only the role interfaces that make sense for it. A client depends only on the role interface it cares about, so unrelated changes elsewhere simply cannot reach it. At the top you see the fat interface worker. It bundles work, eat, and sleep together. Below it we split that into two role interfaces, workable which only declares work, and restable which declares eat and sleep. Human worker implements both because a human genuinely needs all three methods. Robot worker implements only workable. There is no eat or sleep stub, no thrown error, nothing fake. The function startShift accepts a workable, so it can receive either a human or a robot without knowing anything else about them. If we later add a take vacation method to restable, robot worker is completely untouched. The key mechanism is simple. Clients import and depend on narrow role interfaces rather than a wide monolithic one. When a capability changes, only the classes and clients that declared a dependency on that specific role interface are recompiled or retested. Everyone else is invisible to the change. The trade-off is that you end up with more interface declarations to maintain, so clear, intention-revealing names become essential to keep the codebase navigable. Reach for this principle when you notice classes writing empty stubs or throwing not implemented errors, or when a single interface change ripples through unrelated classes. That is a clear signal. The interface is serving too many masters. It is especially valuable in library code with diverse consumers. Skip it when an interface is already small and cohesive, or when every implementer genuinely uses every method. Splitting in that case just multiplies declarations without reducing coupling. To wrap up, the interface segregation principle is a rule about dependency hygiene. Keep your interfaces narrow and purposeful, so that each class and each client depends only on the capabilities it truly uses. When you see empty stubs or not implemented errors, that is your cue to split. The trade-off is a few more interface declarations, but the reward is a codebase where changes stay local and surprises stay rare.